All right, welcome back. So this is our final piece of chapter 8. Congratulations, you've made it. So in this final piece, now we're just going to have a little bit more complication because now instead of just monomials in the denominators, we're going to have binomials in the denominators for us to be dealing with. So the process is actually going to be exactly the same, but now the only difference is we are also going to be dealing with binomials. Because of that, what I want you to do, put parentheses around it just because I want to make sure that you don't end up multiplying by things that you don't want to or don't need to. So, looking at this. So, we have a common denominator so far of n minus 8. However, that minus 1 doesn't have it yet. So that minus 1, it needs n minus 8 on top and bottom. Okay, so when we do that, we end up with this. All right, so now that I have that, now that I've made that common denominator, now you can see just like we did before, if I multiply everything by that n minus 8, notice every denominator cancels off, and all I have left is what was in those numerators. Okay? So, kind of cool. So, not any different than what you did yesterday, just now applying it with those binomials. And now all we have to do is finish solving. Well, let's distribute that negative 1. So here, 1 plus 8 gives me 9. So now I'm going to subtract the 9 off from both sides, then divide by negative 1. That's going to give me a solution of n equals 2. All right, so now I have that. So now let's take a look at this next problem. So here, this time, I have two different denominators. So the common denominator is going to be the combination of them. So what that means is this first one is missing the x minus 2. The second one is missing the x plus 2. Oh, sorry, I wanted to do one on top and one on bottom. I apologize. And the 1 is missing both. All right, so this is going to look a little bit messy for a second, but what I have here is 2 with the x minus 2 with the common denominator. I have that x with the x plus 2 with that common denominator. Then over here, I have both of them with that common denominator. Okay, so now notice those common denominators, if I multiply both sides by it, it cancels absolutely everywhere. Okay, so that's kind of the power of finding the common denominators, is I can multiply the both sides by it and it's completely gone. So now all I have to worry about is simplifying the tops. So let's simplify them. Here, let's distribute that 2. So I have 2x minus 4. Distribute the x to get x squared plus 2x. This we're going to FOIL. So when you do, you get x squared 2x minus 2x cancels off. And so the last step, we just get a minus 4, which shouldn't surprise you because you know that's kind of that difference of squares pattern happening there. All right, so let's keep simplifying. So I have that x squared on both sides. So I'm just going to subtract it off right away. Okay. So here I'm going to get 4x minus 4 equals negative 4. Okay, I'm combining those two x's. Add 4 to both sides. 4x equals 0. Divide by 4. And you'll get x equals 0. Okay, now let's just make sure that x equals 0 works. Now, notice it does not make you divide by 0 at all, so that is actually a perfectly acceptable solution. You can get 0 as a solution to these, okay? So, oh, I'm sorry. So now let's see what happens when I have something that looks like this. Okay, so in this one, notice now I have a factoring that can happen. Okay, so I'm going to have, oh, not x, that's going to be r. So this is really r minus 2, r minus 5. Okay, so when you can factor the denominators, remember, factoring is all over this chapter. So once I do that, now I can see what's going on here. So every piece already has that r minus 2, but these are missing the r minus 5s. These two pieces right here. Okay? So I have to incorporate in those r minus 5s. So what does that give me? Well, it gives me this for my first fraction. The second fraction doesn't change at all. It didn't need anything. It already had the complete denominator. So by adding those r minus 5s into the other sides, or I should say multiplying them in to the other pieces, now I have my common denominators. Once I have the common denominators, I'm going to multiply both sides of my equation by it, and essentially it cancels it off of everything. So I'm going to have only the numerators left to deal with. So r minus 5 plus 1 equals 6r minus 30. So this is really r minus 4 over here, 6r minus 30. Let's subtract r from both sides. Let's add 30 to both sides. And now divide by 5. So r is going to be 26 fifths. Okay, don't be afraid if you get a decimal or fractional answer. It does happen in these. Oftentimes it doesn't turn out as nicely as other problems we've done throughout the year. All right, let's do our next example. All right, so hopefully you can see that this is that difference of squares pattern. Okay, and notice the other two denominators are both made up of a piece of that already. They're each just missing one of the pieces. This one is missing the x plus 3, and this one is missing the x minus 3. So I'm going to get the common denominator first. There's my first one. Here's my second one. Sorry, this is going to be really tiny writing. But, and there's the third piece, which already had that full denominator. All right, so now that I have the common denominator, I multiply both sides by it. So the common denominator cancels everywhere, and all I have left are the numerators. So let's distribute. So I have x squared plus 3x plus x squared minus 3x equals 2. X squared plus x squared is 2x squared. 3x minus 3x, well, that's fun. That just kind of cancels. And I'm left with this. 2x squared equals 2. Divide both sides by 2, so x squared equals 1. I'm hoping you guys remember, how do you undo a square? Well, you need a square root. And remember, when you square root, you need plus or minus. So this is actually a fun one. This one has 2 solutions to it. Okay, x plus 1 and, or x is positive 1 and x is negative 1. So don't forget all of those skills we worked on throughout the entire year still apply in this chapter. All right, so let's wrap up this chapter with a word problem. So, a flight across the United States takes longer east to west than it does west to east. Assume that winds are constant in the eastward direction. When flying westward, the headwind decreases the airplane's speed. When flying eastward, the tailwind increases its speed. The time for a round trip shown at the right is 7 3/4 hours. If the plane cruises at 480 miles an hour, what is the speed of the wind? All right, so they're letting x represent the speed of the wind. And time is going to be rate, or the distance divided by the rate. So notice the distance is constant, right? The rate going west to east, the wind is accelerating you. East to west, the wind is decelerating you. It's making you go slower. So the time, accordingly, is distance divided by rate for both of them, giving you those. And the total time is 7.75, 7 3/4 hours. All right, we want to know how fast is that wind. So now we have some work ahead of us, right? So we have 2 different denominators, right? So what does that mean? Well, that means that 7.75 needs both the 480 plus x and the 480 minus x on the top and bottom. All right, this middle piece just needs the negative 1. And that last one only needs the positive. Now, that looks a little bit messy, but let's write it out so it's a little bit clearer to see, all right? So, 480 plus x, 480 minus x times 7.75 over that common denominator equals to 1,850, and that one needed the minus. Oh, I'm sorry. We have our common denominator of both the positive and the negative 1. And the third one needed the positive. All right, so all of that, and we have our common denominator now. Okay, we have exactly what we need. So now those denominators cancel out. So we only have the numerators left. So now we have to look at how in the world do we simplify that? Because that's kind of a beastly looking problem. So the first thing I'm going to do is I'm going to FOIL those together. All right. So first, 480 times 480 is going to be 230,400. 480x minus 480x is gone. So all I have is that minus x squared, still being multiplied by the 7.75. Over here, 1,850 times 480 is going to be 888,000. And on this side, another 888,000, but this time plus the 1,850x. All right, so now let's distribute in the 7.75. So let's take that 230,400 times 7.75. That's going to give us this very large number, minus 7.75x squared equals. Now, the really nice thing is, notice those are perfectly opposite, so they cancel. So all we have left is twice the 888,000. All right. So I'm going to subtract this number from both sides. So this minus that, let's take a look at what that gives me. That's going to give me negative 7.75x squared equaling this. Now divide it by negative 7.75. So x squared equals 207,483.8.71. Now I just have to square root that to get my answer. So my x is going to be about 1,440.4. All right. So again, a lot of work for that one. Now, for a word problem, obviously, I would love for you to completely understand it and how to construct it. But here, again, the biggest thing is just making sure that you know the process. Okay, the process is key. All right, get the common denominators so you can cancel everything out. All right, so thank you so much for joining me throughout this whole chapter. So please make sure you have all of your videos watched, because this is the very end, and have summaries for each of them, and then come back tomorrow ready to do your last practice work for the chapter.